Hi everyone, today we are going to find the simple method for the calculation of dimensional formula. First of all, we already know that the SI unit of mass is kg, length is meter, and for time is second, and for current is ampere. And we use dimensional symbol for mass is capital M, and length capital L, and for time is capital T, for current is ampere. So first of all, we are going to find the dimensional formula for velocity. We already know that velocity is equals to displacement upon time, and we know that displacement is distance. So for the distance, the unit is meter and the symbol is L, and for time is symbol is T, and it will become LT, and T in denominator will become -1. So if you want to write this in the form of MLT, so M is 0, L is 1, and T is -1. You have to remember this, that mass is not present here. So the second we are going to calculate for acceleration. We already know that acceleration is equals to change in velocity per time. So change in velocity is displacement upon time and divided by time. So it will become, for dimensional formula for displacement upon time, that is velocity, will be LT -1, and for time is T, and it will become T. T in denominator become -1, and when we add this it will become T -2. So the dimensional formula for acceleration is LT -2. The third we are going to calculate for force. We know that force is equals to mass into acceleration. The symbol for mass is capital M, and for acceleration we already find the dimensional formula, that is LT -2, and it will become M⁰L² -2. That is the dimensional formula for acceleration. The next we are going to find for pressure. Pressure is force upon area. We already find the dimensional formula for force is M⁰T -2, and for area we know that length into breadth. The symbol for length and breadth is same, that is L dot L or L into L, and we write this as, firstly cancel the length, M⁰L−1 T -2. That is the dimensional formula for pressure. And the next we are going to find for stress, that is equals to force upon area, the same dimensional formula as pressure, that is M⁰L−1 T -2. Next is modulus of elasticity, that will equals to stress upon strain. We know that strain is unitless quantity. So we already calculate the dimensional formula for stress, that is M⁰L−1 T -2. So the pressure, stress and modulus of elasticity have the same dimensional formula, that is M⁰L−1 T -2. Next we find for work done and energy. We know that both are same quantities. So work done will be equals to force into distance. We already calculate the dimensional formula for force is M⁰T -2, and we know that the symbol for distance is L, so it will become M⁰L² and T -2. The next we are going to calculate for torque. It will equal to force into distance, so it is same as the work done, M⁰2 T -2. And the next for kinetic energy, that is half mv². You have to remember that constant quantity not included in dimensional formula. So for mv², symbol for mass is capital M, and v is velocity. We already know the dimensional formula for velocity is L T -1 and the whole square. Therefore it will become kinetic energy is equals to M⁰2 and T -2. So these three have the same dimensional formula. Work done or energy, torque and kinetic energy, that is M⁰L²T minus 2. Next we are going to find for resistance. We know that from Ohm's law, resistance is equals to V upon I, or V is equals to IR. We already know this. Given this equation 1, and we know that V is equals to work done upon charge, and charge is equals to current into time. So put this value of Q here. Work done is current into time. We already calculate the dimensional formula for work done, that is M⁰L²T minus 2, and for current is ampere, and for time is capital T. So the dimensional formula for voltage is M⁰L²T minus 3, and A is A minus 1. M⁰L²T minus 3, A minus 1. That is the dimensional formula for voltage. So we find for resistance, that is R is equals to V upon I. So M⁰L²T minus 3, A minus 1, and for current is ampere. Therefore A in numerator become A minus 2. So M⁰L²T minus 3, A minus 2. This is the dimensional formula for resistance, and the same dimensional formula for reactance and for impedance. There is no need to calculate them for again. They have same dimensional formula. For Boltzmann constant, entropy, heat capacity have same dimensional formula, that is M⁰L²T minus 2 and K minus 1. Same for angular velocity, frequency and angular frequency. There is M⁰L0 and T minus 1. You have to remember this. No need to calculate them. So that's all for today. Thank you.